engine is a Cummins QSF 3.8. The power at 1800 RPM is 74 horsepower. It's 4 cylinders. The bore and stroke is 4.02 by 4.53 inches. The displacement is 229 cubic inches. The aspiration is turbocharged, charge air cooled in EGR. The battery is 12 volts, 950 cold cranking amps at 0 degrees Fahrenheit. The ambient operating temp range is 0 Fahrenheit to 120 Fahrenheit. The generator model is 40 kilowatt alternator. The output is 40 kilowatts prime, 44.5 kilowatts standby. The voltage is 208 to 240. The amps is 142 at 208 volts, 134 at 220 volts, 123 at 240 volts. The compressor is an integrated air compressor. The type is an oil-flooded rotary screw. It delivers 40 CFM, and the operating pressure range is 80 to 130 PSIG. The oil sump capacity is 0.75 gallons, and the total system capacity is 1 gallon. The type of cooling system is oil to air, and the air intake filter is single stage dry. The type of control is 0 to 100% demand, and the air service connection is a 1/2 inch NPT. Here you can see the size and the dimensions of the machine. Cummins QSF 3.8 engine. The Cummins engine in the GCR S40 is a 74 horsepower unit that powers both a 40 kilowatt generator and a 40 CFM compressor simultaneously. Utilizing an onboard or removable diesel fuel tank, this engine is capable of running in an ambient temperature range of 0 to 120 Fahrenheit. The open skid design allows optimal airflow, cooling, and the ability to mount in limited space environments. Synchro 40 kilowatt generator. The Synchro generator installed on this package is capable of 40 kilowatts at up to 240 volts continuous. This 60 Hz unit can be wired in either 3 or single phase operation directly to the generator itself. The generator design utilizes a through shaft to belt drive the compressor at the same time. 40 CFM rotary screw errand. The rotary screw errand is an oil-flooded, encapsulated unit which separates internally. Capable of 40 CFM at 80 to 130 psi continuously, this errand is the ideal pair in this package. The air filter, oil filter, and coalescer can be easily serviced with minimal tools. The air discharge to tools is connected by a 1/2 inch service valve exiting the right side of the compressor. This is a diagram of a rotary screw errand. You can see the air intake system, which includes the air filter and inlet valve, the regulator valve, the blow-down valve, the oil fill location, the high oil level sight glass, the low oil level sight glass, the spin-on coalescer, the oil return line, the spin-on oil filter, the thermal valve, the return line check valve, and the oil drain. Thermal and minimum pressure valve. The minimum pressure valve is designed to hold back 55 psi internally to maintain the proper flow of lubricant in the circuit. If all air was exhausted, the flow of lubricant would stall, causing the compressor oil to stop movement and starve the compressor rotors. This will cause either an over-temperature shutdown or an air in failure immediately. The thermal valve is designed to bypass oil flow to the cooler until 175 degrees is achieved. This will preheat the lubricant and prevent starvation of oil to the compressor. Once 175 degrees is reached, the thermal valve shifts, allowing full flow through the cooler and cooled oil returned back to the compressor. Oil return line and check valve. The oil return line removes the excess lubricant from the coalescer and returns it to the compressor. Due to a suction in the compressor and a positive pressure in the coalescer, the oil is siphoned out the scavenger tube and removed. The check valve allows the oil removed from the coalescer to enter the compressor, but not in reverse. When system pressure equalizes, this check stops the ability of lubricant to backfill into the coalescer and end up downstream in your tools. Air and oil schematic. The belt spins the compressor shaft and the rotors begin to spin. As the rotors spin, a suction is created and fresh air is drawn into the system. The air is combined with the oil and is sent down the rotors once. This compressor mixture is sent into a screen where the oil drops out and the air rises to the coalescer. While 90% of air-oil separation happens in the tank, the final amount of oil is removed in the coalescer. Separated oil is dropped out and sent to the cooler. Oil is returned from the cooler, cleaned by the oil filter, and returned to the rotors. Clean air discharge for tools. The Boss cooler package utilizes a single-pass tube and fin-style radiator system to properly cool the engine and compressor system independently. The standard drop across the cooler should be 30 to 40 degrees. The standard shutdown temperature on the engine is 220 and 245 on the compressor. The blower fan is driven off the engine itself. Murphy instrument panel. The instrument panel is located on the front corner of the unit and is used to mechanically and digitally monitor and start the generator system. This panel uses a mechanical ignition switch for start run, but a digital panel to monitor vital information. This panel displays RPM, PSI, hours, pressures, temperatures, and much more. The unit will start in warm-up mode, but automatically adjust up to a high speed for operation. Lubricant used: Boss Shieldworks Plus, ATF 3, ATF 5, 6. Servicing your compressor. The oil filter and lubricant should be changed every 1,000 hours or 6 months. The air filter and separator element should be changed every 1,000 hours or 1 year. Oil level. The oil level in the compressor should be between 1/2 and 3/4 of the sight glass. Should be checked in the off position on level ground. Oil cooler cleaning. Depending on the severity of the environment and the location of the system, the cooler system should be periodically checked as needed. Belt tension. The compressor belt tension should be inspected after the initial 8 hours of operation. The proper belt tensioning is 1/4 inch deflection at 5.78 to 8.58 pounds of force on a double-banded belt. Blowdown valve. While in the running position, the blowdown valve is closed. When the compressor is shut down and system pressure equalizes, the blowdown valve shifts internally, allowing system pressure to vent to atmosphere. Regulator valve. When you achieve the desired pressure, the regulator sends a 30 psi signal to the inlet valve to close. If this signal is not sent by the regulator, the system will overpressure. Broken drive coupling. The drive coupling is the connecting source between the engine and the generator. The through shaft at the rear of the generator drives the compressor. If you have no belt drive at the rear of the engine running, check the drive coupling. Shutdowns. The system can shut down for the following: engine oil pressure, engine coolant temperature, in compressor oil temperature. Restricted oil flow. A restriction in the oil flow will cause a rise in compressor temperature and eventual shutdown. While the separation is done internally, oil does leave the compressor to be cooled and returned. These are the common parts needed to service your machine. The air filter element, which is 311404, the oil filter element, which is 310852, the separator element, which is 311074, the drive belts, which is 306927-500, shield wicks, which is the lubricant in 1 gallon, which is 312480-1G, or the shaft seal repair kit, which is 307117. Engine speed. The engine speed should be at 1800 RPM. At this speed, the user will have the full 40 kilowatts on the generator and the full 40 CFM on the compressor. Anything under will cause erratic output of the generator and compressor. Water and fuel. If the user is using a system that has water injected with the fuel, they will experience erratic idling in performance, or the engine may cut out momentarily, especially during the engine speed ramp-up process. Fuel pump. The fuel pump automatically injects a certain amount of fuel into heated, high-pressured air that automatically ignites it. If at any time your fuel pump becomes inoperable, you may not be able to provide sufficient fuel to the engine. Voltage regulator. The voltage regulator is designed to automatically maintain a constant voltage level with a constant 1800 engine RPM supplied. Rectifier. The rectifier is an electrical device that converts alternating current, which periodically reverses direction, to direct current, which flows in one direction through the diodes. A faulty diode would have high resistance in both directions or low resistance in both directions. Loose wires. Loose connections can cause heat to build up. This can cause breakers to prematurely trip and potential loss in voltage, components to fail, or even electrical fire. Overspeeding the generator. Overspeeding the generator is any operating RPM above the 1800 engine RPM. This often leads to serious damage to internal components such as the rotor, shaft, and windings. Underspeeding the generator. Underspeeding the generator is any operating RPM below the 1800 engine RPM. With the generator running below the required speed, this lowers the output to equipment. This can do extensive damage to the attached equipment running at a voltage well below the required setting. If any questions, please take a look at the following wiring diagrams on this slide and the next slide. Louver size. To avoid potential overheat issues, the exhaust louvers should be sized to a minimum of 6,000 CFM at 1 inch H20 and at least 27 inches height and 23 3/4 inches width. To ensure adequate fresh air flow, the air intake louvers should be at least double the size and performance of the exhaust louvers. Radiator cooler cleaning. Depending on the severity of the work environment, the radiator cooler package should be checked frequently. If a rise in engine or compressor temperature occurs, the overheat inspection may lead to here. With the tube and fin design, dirt and debris can stick to the tubes, causing the cooling package to not run as efficiently as possible.
This video is a supplement, but not a substitute for the user manual of this product. It is important to also read the user manual. Also, since we are continuously improving our products, changes may have been made in the product you have compared to the product shown in the video. Please call 800-635-6587 to be sure this video applies to the product model you have.